For our last video of week 2, we're going to be talking about how to calculate probabilities for a binomial distribution. As we saw in the last video, building a probability distribution for a binomial distribution by hand can be kind of tedious, and our calculator can give that information to us. All the calculator is going to want is the number of trials n, the probability of success p, and if we're calculating the probability not for the whole distribution, but for a specific outcome, we need the number of successes. The two commands that we're going to be using on our calculator are going to be binom PDF and binom CDF. We know PDF means probability distribution function, and we're going to use binom PDF for questions where we have x is equal to a number. We're going to use binom CDF, where CDF means cumulative distribution function, for x is less than or equal to a number. If we have a question that's an inequality, it's a range of values, but it's not less than or equal to, we're going to have to use our knowledge of the number line and the complement trick to rewrite it as a less than or equal to. Before we get started, to find those probability functions, we need to look in the distribution menu on our calculator, and to do that, we're going to press second, which is our blue button here, and then we're going to press the vars button. Because above the vars button, you'll notice it says DISTR for distribution. That's our distribution menu. And you'll see a whole lot of stuff, none of which says binomial. Binomial is off the screen towards the bottom. Options A and B are binom PDF and binom CDF. Let's go ahead and take a look at our example and look at these in context of a problem. So our example says, a report from the Secretary of Health and Human Services stated that 70% of single vehicle traffic fatalities that occur at night on weekends involve intoxicated driver. If a sample of 15 single vehicle traffic fatalities that occur on a weekend night is selected, and then it's going to ask us to find some probabilities. I know in order to do calculations in my calculator, the very first thing I need are the number of trials and the probability of success. We're told in the word problem that we're looking at a sample of 15. So that's my trials, 15 trials. They also tell me that a study from the Health and Human Services Agency said that 70% of single traffic fatalities fell in this category. So that's the category we're calling a success, and that is our probability of success. So our first probability says, find the probability that exactly 10 accidents involved drivers who were intoxicated. So the phrase exactly 10 means the number of successes is equal to 10. So they're asking me px equals 10. And I remember from earlier in the notes, if it's x equals a number, it's binom PDF. So to find this, I'm going to go to binom PDF. So second vars, and I'm going to go down to the bottom here and select binom PDF. And it asks me for three things. It asks me for trials. It asks me for probability for success. It asks me for x value. So the number of trials is 15, and the probability of success is 0.7. That's going to be true for every probability we calculate for this example. and then the x value of interest is 10. So we're going to go ahead and put that in our calculator. And then we hit paste, and then we hit enter to run it. And it tells us that px equals 10 is 0.20613 something something something. And remember, we typically round probabilities to 4 decimals. I'm going to show you a neat trick on your calculator. If I wanted to build that table that we built the last time, I would create a list. So stat enter, and let me clear out my old data. And I would put my x values in this first list. For this problem, we have a sample of 15, so I'm going to put 0 through 15. No intoxicated drivers, 1 intoxicated driver, all the way down to 2 intoxicated drivers. In the next column, what I want the calculator to do is calculate the probability for me. I want it to build the probability function. So I'm going to go up to the list header, and I'm going to feed it what I want it to calculate. I want it to run binom PDF. And I want it to run binom PDF on list 1. And notice it pastes the command here. Number of trials, % success, x value I'm pulling from. And when I hit enter, notice that it fills out that whole table for me all at once. And if I scroll down to 10, you'll notice there's that 0.2061 that we calculated by hand. So this is really nice when you're asked for a binomial probability distribution. The table can do it for you. We're going to go back to our home screen by hitting second mode. And we're going to take a look at our next example. So our next example says between 10 and 15 inclusive accidents involved drivers who were intoxicated. So they're asking for x between 10 and 15 with the endpoints included. And I have a problem. I know that my calculator can only do x is less than or equal to a number. So my calculator knows how to deal with x is less than or equal to 15. It doesn't know how to deal with x is less than or equal to 10. So what I'm going to do is I'm going to construct a number line from 0 to 15. I'm going to look at the values I'm interested in, and then I'm going to use the complement trick. So let's list the numbers we're looking at. So we're from 1, or 0 rather, all the way to 15. Oh, I'm going to need more room. Nope. Okay, so I'm going to use a highlighter, and I'm going to highlight what we have in yellow. So 10 is included, 15 is included. I want all those values between. The problem is my calculator can't do that. So what I'm going to do is I'm going to start looking at where those numbers leave off. The numbers that are not included start at 9 and go down. So this region is the 10 less than or equal to x less than or equal to 15. The region in green is x is less than or equal to, and it starts at 9. So this probability, the probability that I'm between 10 and 15 inclusive, is the complement of the probability that I'm less than or equal to 9. So I'm going to use the complement trick. So on our calculator, I need to enter the 1 minus before I enter the binom PDF or binom CDF. So 1 minus, and then I can go to my distribution menu, second vars. In this case, I am looking at an inequality. I want a CDF, cumulative, not a PDF. Other than that, it asks for that same information. Number of trials was 15, probability of success was 0.7, and we're starting ours at 9 and going all the way down. And when I do that, I get 0.7216. And I'm going to go back and check that with what I saw in that binomial distribution table that I built. So if I start looking at the sum of 10 through 15, I've got 0.2 and 0.2 is 0.4. That's going to be about 0.6. That's almost 0.7. That's going to put me at a little bit over 0.7 collectively. So adding up those probabilities individually gets me the same thing that I got from my complement trick. In general, and I'm having a brain fart here. What I could do if I wanted the yellow region is I could calculate from 15 all the way down to 0. I could calculate from 9 all the way down to 0. And then I could subtract, and what I would get would be this area here. So let's try that second method. If I did binom CDF for the bigger output first, whoops, that's Poisson. We don't want Poisson. We want binom. So 15.715 first, and then minus, and then second vars, binom CDF for 9. Notice it gives us that same probability. So in this case, where I have a probability A less than or equal to X less than or equal to B, I want to treat that as P X is less than or equal to B minus P X is less than or equal to A minus 1. Because I want that lower endpoint included in the upper part, so I want to start my lower part below that. This can get really hard to memorize really quickly, so my suggestion, draw the number line. If you can figure out what you have and what you want and write it in terms of an inequality, that'll make your life a lot easier. We're going to do another 2 examples just to give us some practice with that process. So for our next example, it says less than 8 accidents. Less than 8 accidents. So we want P X is less than 8. So on my number line, and thank you for your patience while I draw this. What I want is less than 8, meaning I'm going to start here at 7 and go down. My calculator doesn't have a command for less than, but it does have a command for less than or equal to. and my equal to condition starts at 7. So when I do this on my calculator, I want to do binomial CDF, number of trials, probability of success, and then my number of successes will be 7. So let's go ahead and run that on our calculator. Second parse binomial CDF, and it remembers the number of trials and probability. I just have to change that to 7. And we get 0.0500. All right, next one says more than 11 accidents. More than 11 accidents. So PX more than 11. And again, my calculator doesn't know how to do greater than, so I'm going to pull that number line down and we're going to recolor it. So for this number line, greater than 11 means I'm going to start at 12 and go that way. My calculator doesn't know how to do that. So I'm going to rewrite it as starting at 11 and going that way. And because those two together make up the whole number line, this is a complement trick. So I need to do 1 minus P x is less than or equal to, and that guy started at 11. So on our calculator, remember 1 minus, and then we pull up the binomial PDF. Whoops, I did not mean to hit trace. Sorry about that. And then we want our x value to be 11. What happened there? That is not what I meant to do. Let's try that again. Home. Come on, go. And then I'm in a second insert, sorry. There we go, that looks better. And we get 0.2969 if we round up. And that makes sense. We know that the bulk, if we scroll up, of our numbers are between 10 and 15, so 10 or higher. So I'd expect 11 or lower is not as much of the data. And looking at our binomial distribution again, I can see that those numbers down between 0 and 4 are so small that they're given in scientific notation with really big negative exponents. It isn't until I hit x equals 6 that I get a percentage that's about 1%. So it makes sense that from 11 down to 0 is small. Okay, so the next two, I would encourage you to pause your video. I'm going to go ahead and pop up the answers, and you should check your work to make sure that you converted those probabilities into the correct form for your calculator. For question E, no more than means less than or equal to. Means that value is the cap. I can't be bigger than that, but I can be equal to. So this is x is less than or equal to 9. And binomial CDF evaluates less than or equal to. So this is a straight binomial PDF function call, and you should get 0.2784. For question F, no less than means 13 is the lower boundary. I have to be 13 or bigger. So this is x is greater than 13, and I can't do greater than or equal to, so I'm going to use my complement trick, 1 minus, and then the number that's smaller than 13, where I'm going to pick up my less than or equal to, is 12. And when you run that calculation, you should get 0.1268. Again, when you're doing these calculations, remember to draw that number line. It'll help you reason it out. And if you have questions, feel free to send me an email or drop by office hours on Thursday. this is our last video for the week, so I will see you again in week 3.